Now I'd like to work through 4 examples of finding derivatives. Once again, first one we could do using the definition or first principles, but we'll go through and use our rules. Now, we do have a rule for ax to the n, and all we do when we've got 3 terms here is use that rule for each of them. So we can say that if f of x is equal to that, then we can write it as just f dash of x will be the derivative. That's like writing dy dx is equal to. Now the rule is that the power comes down, so it'll be 2 times 3 x, and then you take 1 off the power, so 2 minus 1 will be 1, minus, now x is like x the power of 1, so it'll be 1 times 5x to the 0, plus, now 6 is like 6x to the 0. Don't forget that power only applies to the x, and anything raised to the power of 0 is equal to 1. So the number 6 is like 6x to the 0. So the power's got to come down, so it'll be 0 times 6x to the 0 minus 1, which is negative 1. That's one way of looking at it. Another way to look at it is if you were to plot y equals 6 would just look like that through there. Now the gradient of that line, which is what dy dx is equal to, is the gradient, and the gradient of that will be 0 because the rise is 0. Certainly we have a run as we move from left to right, but we don't have any rise. So a general rule is that the derivative of any constant number is just equal to 0. Well, 0 times this has got to be equal to 0. So most of you, once you get used to this, you won't write that line down. You'll actually just go to this line, and we say that 2 times 3 is 6, 1 off the power x, the 1, minus 5, 1 times 5 is 5, x to the 0 will be equal to 1, so it'll be just minus 5, and the derivative of a constant, as we've seen, we've got 2 explanations there, but the derivative of a constant with no x's in is just equal to 0, so there's our answer. So we got 6x take 5 as the derivative of 3x squared. Now that says that the gradient at any point on that curve can be calculated by just finding the x value or having the x value substituted in here, and that'll give you the gradient. Okay, so we apply our table of rules, which we did in the previous talk, to this one as well. And the 2 comes down, don't forget, the 2 up here has got to come down. 2 times 3 is 6, e, and we don't take anything off. When we've got e to a power, we just write that power again. So it'll be just 6e to the 2x minus, now a constant out the side the function will be just 5 times the derivative. This is a constant, it'll be the derivative of ln x. We know the derivative of ln x is 1 over x, and the 5 will be up the front, so it'll be 5 times 1 on x, and probably a better way to write that is this. The first term's okay, e to the 2x minus, now 5, you can multiply the numerators out, 5 times 1 will be 5 over x, so that's probably a better way to write it. This one here, we've got x's in the numerator and the denominator, so we will try and simplify this to get a single term in x. So we can split this up as, now that square root applies to the 3 and to the x the 5, and don't forget a square root sign is nothing more than to the power of a half. If it was cubed root, it would be the power of 1/3. So as an intermediate step, it might be wise just to put whatever's underneath the radical sign, which is 3x to the 5, and raise it all to the power of a half over 5x squared. This is raised to the half, so it will be 3 to the half. Now when you raise a power to another power, going back, you multiply the power, so that'll be x to the 5 on 2. all over 5x squared equals, you've got 3 to the half over 5 to the 1. And now when you're dividing, you subtract the indexes. So 5 on 2 is like 2.5. So it'll be x, so you've got to take 2 away from 2.5 or 2.5 and you get x to the half. So you can put x to the half on top or just write it as x to the half. Okay, so now we've got to find the derivative of that, so h dash of x. So you do the simplification first. You've got a single power, a single term, or a single x in the term here now. And so it's the same. Here is my constant. So the half has got to come to the front. A half times 3 to the half over 5 times, now we take 1 off the power. When we take 1 off a half, we get minus a half. So a half minus 1 is a half minus 2 on 2. 1 is the same as 2 on 2. And that'll be equal to minus 1 on 2. So we get x to the minus a half. We can multiply out the 2 times 5 and the 1 times that. And so we get 3 to the half over 10. Now anything to the negative power can be over to the positive power. So we've got x to the minus half in the numerator, so we can take it downstairs, put it in the denominator and put it to the positive half. Now we know that square root is to the power of a half. Square root is to the power of a half. So this can be root 3. So root 3 on 10 and times 1. So that'll be root 3 on the numerator. 10 times, now x to the half is square root of x. So there's an answer for the derivative. So it'll be root 3 over 10 root x. Lucky last. We want to find the derivative of that. No need to, we can just say no need to simplify here because it's all okay. The constant stays out the front. The derivative of cos is negative sign. So it's conventional, put the negative right out the front. So the derivative of cos is negative sign. The constant just stays where it is. This is like, now that'll be like minus 3. Now because it's the power of 2 downstairs, it's going to be x to the minus 2 upstairs. Okay, so that x to the 2 when it comes up there becomes x to the minus 2. Now when we do the derivative of that, the negative 2 is times the negative 1, so we'll get plus 2. So we multiply the power times what's out the front, which is negative 3. So negative 2 times negative 3 is positive 6. Negative 2 times negative 3 is positive 6. And then x, take 1 off the power, so we've got minus 2 minus 1 is negative 3. So go through that again. The derivative of 4 cos is just negative 4 sine. 3 over x squared can be, well, it's minus 3 over x squared is the same as negative 3x to the minus 2. Bring this upstairs and it becomes to the minus 2. And then the negative 2, the power gets multiplied by the first coefficient here. So negative 2 times negative 3 is positive 6. And then you take 1 off the power and you get to the negative 3. This stays as it is for negative 4 sine x. Because there were no negative powers in our original question, we shouldn't put our answer here with a negative power, so that now can come down. The 6 will say that negative 3 only applies to the x, not the 6. So it'll be plus 6 over x to the minus 3 becomes x to 1 over x to the positive 3. And so there's the derivative of that one.